Hi, in this video we are going to learn how to express a discrete time signal x of n as a sum of pulses with different amplitude. Well, first, how can you express this pulse? The one to the left. It's equal 1, right? So you say that when n is equal -1, x of -1 is equal 1. The second one, when n is equal 0, that's when n equals 0, x of 0 is equal to. When n is equal 1, x1 is equal 3. When n is equal 2, x of 2 is equal 2. When n equal 3, x of 3 is equal 1. There are many ways to express this discrete time signal. For example, you can write xn and you start to put all elements from left to right. Start from 1, 2, 3, 2, 1. And you should mark the element where n equals 0, which is equal to, you put underline here. So that's one expression. Okay, how you express it as a sum of impulses? All right. For the first one, at n equal -1, x is equal 1. Where is located, this pulse? At -1. So you can write it like 1, that's the amplitude, delta n plus 1. Why we write n plus 1? Because it's shifted towards the left. Well, maybe we do the other one at 0. At 0 there is a pulse, the amplitude is equal to, and at n equals 0, so we said delta n. That's the definition of delta n. Delta n is impulse, which will be equal 1 when n equals 0 and 0 otherwise, other places. That definition of delta n. All right. So this one is delta n, but the amplitude is equal to, you write it like 2 delta n. All right, let's go here. That will be the amplitude is equal 3 delta n minus 1, shifted 1 towards the right. Then you have pulse at 2, and the amplitude is equal 2. So that's 2 delta n minus 2. The last one, the amplitude is equal 1, and delta n minus 3. And you can express x of n as the sum of all these impulses. B1 delta n plus 1 plus 2 delta n plus 3 delta n minus 1 plus 2 delta n minus 2 plus 1 delta n minus 3. So that's how we make the sum. Let's write it in more general term. For example, pick any term, like I'll just pick this term, for example. 1, that's the value 1, which represents the value of x at n equal 3. That's x3. All right, so that's x3 multiplied by delta n3. If you like to choose another index name, like say k is equal 3, when k is equal 3, so this term, instead of writing 3, replace it by k, you will write it as x of k delta n minus k. So this is a general term, you can use it for anyone. All right, let's check. For example, this one. Well, 1 delta n plus 1, and should be equal x k delta n minus k. So compare these two things, you'll find 1 is equal minus k, so k is equal -1. -1. So this term, x of -1 delta n plus 1. Okay, and x when n equal -1, you'll see it is equal 1. That's right. So this is general term. So each term in this series can be expressed by this term. So now in the end you will say xn is equal to the sum xk delta n minus k, and k could take any value between negative infinity and positive infinity. So this is the way you express any discrete time signal. Thank you.